Little quick look at Venus there, and just another nice sunset here. Not much going on here in Texas. Getting a little bit more of the moisture though. Got a bit of a stratus feed up through here, cloudy mornings, that kind of thing, and you can definitely see that on the surface map. This is more of a deep flow of southerly air than we've had in probably months. So you see that very strong southerly gradient there. Got a 996 millibar low up there around Pratt, Kansas, and 1012 millibar pressures off the Louisiana coast. So a bit of a gradient there. And there's a look at the temperatures there. Unseasonably warm. Lots of 80s across Texas, and dew points are up in the 70s in a few parts of the San Antonio area. So I can just draw that out very quickly. It actually looks like maybe one spot there around Austin, and the rest of it just offshore here. Picking up at 76 there down in Corpus Christi. So the moisture is pretty close, and the actual axis of that is probably going to be out in this area of Louisiana, because I can see lots of 68-degree readings for dew point, and a lot less of that out west. But where they are getting some definite action is up north in Minnesota and the UP of Michigan and northern Wisconsin. And you can see pretty much what's causing that. We've got a front sinking south. If we fill in the highs and lows, we're going to come up with something like that. Maybe another low right here in southern South Dakota. And we would probably place the front something like this. Maybe even further south like that. So these are definitely frontal systems, and the storms are occurring in the warm air advection wing of that frontal system. We can take a closer look at that on the radar. This is the WSR-88D from Marquette, Michigan. And you can see nothing really looking supercellular here. This looks like a giant MCS. And the cells themselves are not even clustered along the leading edge or on the up shear side. So these are pretty much all in the non-severe category. The few cells that are severe are the ones down here. You can see they have more of a cellular appearance, and they are closer to the unrestricted inflow from the south. If we take that radar higher, go up to 5,000 and go up to 13,000, we see a slight bit of tilt there. You can see the tops are right in this area here. Those are up at about 26,000. So they're sitting over this area. That could actually be associated with this cell right here. So let's see here. Yeah, that's definitely the case. The tops on that stuff to the south are right there. So this is up at about 14,000. Compare that with low-level features, and we see just a very slight amount of tilt there. So that's not helping the storm longevity very much. And the rest of it just looks like disorganized multicells all over the, I don't know this terrain very well, Rhinelander, all the way out towards wherever this is, out near Green Bay. So that's what's happening there in the UP of Michigan. Oh yeah, let's take a look at the large-scale picture. And to do that, we really should look at the model guidance. So let me pull that up very quickly, and we'll go to the GFS for North America. Look at the 1,000 through 500 millibar thickness. And just as a reminder, this is the average temperature in the lower 5 kilometers of the atmosphere. So this kind of gives you just a general isotherm that's not disrupted too much by terrain and station elevation and that kind of thing. So what do we see here? We see a definite front extending east-west across the Rocky Mountains. We place that front south of this main gradient area. And today it's very easy to find. There it is right there. And just as a note, this is a 7-hour forecast from 18Z, so this is actually current data. We're going to look at slightly different data in just a minute. So that's the general picture right there, and you can see southerly flow coming up north ahead of that system there. And then cold air advection back behind it here. All right, so let's check out the data just a little bit closer. Can we see the front in the surface data here? Yeah, we definitely can. Plotting out the wind direction very quickly, we come up with something like that. Yeah, so there's a major difference here in the air masses between these two. So we can use that pretty much to place the boundary like that. Now the main discriminator we should be using for this is temperature, but it's very hard to compare temperatures in mountainous areas like that because of station elevation differences. So we kind of use wind as a proxy and sometimes the dew point. But here, yeah, you can really kind of see the temperature difference. We have 50s and even a few 40s up in this cold sector and down to the south. Very warm conditions, 76 there in the Four Corners area. So that kind of stands out as a very prominent example of a strong front in the Central Rockies right there. Now another way we can really pick that out is to look at the satellite data. This is the polar orbiter data from Terra. And going from south to north, that's kind of a good way to look at this. So let's see here. Let me get my geography oriented. I believe that's the Mogollon Rim right there. Yeah, so this is Arizona right here. And Phoenix is located right there, and Tucson just to the south on the bottom edge. Flagstaff is about right there. So what we see here is Bit of a lee side cirrus, indicative of strong jet stream winds. Then as we go north, we pick up what looks like a boundary. In fact, kind of looks like a line of cumulus right here. So that goes from about Aspen, west-southwestward to about Cedar City, Utah. And that was about noon today. And you can see that the clouds go to a more closed cell appearance as you go north, as you get deeper in that cold air. Whereas down to the south, we have more of an open cell appearance. Now, another way we can look at this is to check out the soundings at Grand Junction right here. Not the soundings, actually. I mean the trends, the METAR trends. So keep in mind our boundary looks like it's just passing through there at midday, maybe a tiny bit to the north. So we take a look at the soundings for Grand Junction, and we're looking at increasing time as you go up the page. So this is going to be about dawn right here. 11Z, that's going to be about 6 in the morning, and then the current conditions are way up here at the top. So what we see here is a transition from west-southwesterly winds in the late morning. See temperatures up to about 24 Celsius. That's about 75 Fahrenheit. And then sometime around mid-afternoon, we see things become more northwesterly. We get the strong northwesterly flow coming in, and temperatures have dropped to the upper 60s. And by sunset, they're down into the 50s already. Now you can kind of compare this with yesterday's data. If we look at this and find the peak temperature, that's right at 21 to 22 53Z. So we're looking for that peak heating to be right here. And what do we have? We have 20 to 21, whereas an hour earlier we were 23. So we're getting temperature falls here. So it looks like a front is passed sometime right around slightly after that satellite image was taken. So that's an example right there of putting all your tools together. Okay, let's see here. Okay, what are we going to cover next? I guess we'll do our forecast chart here. So here's the GFS analysis. And of course, I've always got to position this map very carefully so we're not missing out any data. Okay, so we're starting out with this picture here. So our fronts are looking something like that. You can definitely see that front extending through southern Colorado into southern Nevada. So moving forward through the week, looks like that system along the front does not really get going. We can see the boundary right through here, but not really any deep cyclogenesis along that boundary. However, it does kind of hang tight here over Nevada, so anything that's coming upstream is going to pick that up. So in the meantime, the boundary just kind of sags southward, and you can see this inverted trough through the Mississippi Valley from around Louisville, Kentucky, down to Dallas. So this is going to be Wednesday night. Pretty good high up here over the Pacific Northwest, and that's driving this density current southward. But really no cyclogenesis along the front yet. So it looks like that sags through Texas by about 48 hours from now. 36 to 48 hours that will be coming through Texas. And you see here, continued very strong front across Arizona, but not really any disturbances upstream to pick that up. In the meantime, we do get a little bit of cyclogenesis here over the Ohio River Valley region. So here's our front. This is Thursday night, and this is heading for New England. So possibility of rain there by the end of the week. And behind it, here comes that 540 line coming all the way down to Illinois. In the latest run, has pulled that all the way down into West Virginia. So it looks like the run is starting to go a little bit colder with the backside of the system. So, yeah, there it is right there. And the western part of that system, looks like we're looking something like that right there. This is Saturday morning here. So the weekend looks pretty dry across much of the country except Washington and New England. Looks like they've both got some frontal system action going on there, a little bit of precip. And then going into next week, looks like continued cold out in the eastern U.S. and mild here in the central U.S. And then we get our next front coming together again. See that right there? Doesn't really show up very well, but it is there coming through the southern Rockies on Wednesday, October 26th. There it is making its way into Texas, changing the weather yet again. And then by Halloween, we're starting to pick up a few panels here. Of course, this is all just conjecture, but we can see what the general outlook is. So here's the front. Warm front, that's kind of tricky. Maybe something like that there. So I'll just draw on the barbs really quickly. And then the next Pacific front coming in here. And you see that there. So it looks like it's going to be very Halloween-like from Chicago down to Dallas if this pans out. You know, blustery winds and kind of fair weather back behind the front. And it will be a bit muggy in the southeastern U.S. A little bit less like Halloween. So I guess we'll have some more to look at as these days wear on as we get closer to winter. And I'll just say hello to everybody in chat. I got one question about plot density here. You can fix that by, if you have the newer digital atmosphere version. I don't know if this is showing up, but there's a control right here called data plot crowding. You change that and bring that up and you'll get even denser plots. So you can have some fun with that, certainly. Anyway, that's about all I got for today. I appreciate you watching, and we'll see you at the same time tomorrow. Good night, everybody.